Every single time you watch a video or send a quick email, you're tapping into this massive, invisible postal service that runs our digital world. But have you ever stopped to wonder how a single little packet of your data knows exactly where to go? Today, we're going to pull back the curtain on the hidden shipping label that makes it all work, the IPv6 header.
I mean, it really is kind of magical, isn't it? You've got billions of devices all chattering away at the same time. How on earth does that one little packet from your phone find its way to a server thousands of miles away and then get the answer right back to you and not your neighbor?
Well, the answer boils down to something called a header. And the best way to think about it is exactly like a shipping label on a package you'd send in the mail. It's got all the critical info needed to get your data from point A to point B without getting lost along the way. So let's actually peel back the layers on this digital shipping label. We're going to focus on the one that powers the modern internet, the IPv6 header. And honestly, its design is just a masterclass in getting things done efficiently. The very first thing you need to know about this header is its size. It is always, and I mean always, a fixed, lean 40 bytes. That's it. This fixed size is a game changer because it makes it incredibly fast for network routers, the internet's postal workers, to read and process. No guesswork, just pure, unadulterated speed. And here's the entire map of that 40-byte label. We're going to break this down piece by piece, but you can see the whole layout at a glance. You've got a few bytes up top for instructions and logistics, and then look at that. The two biggest chunks taking up most of the space are for the source and destination addresses. Okay, so let's start with that first part of the header. I like to think of these fields as the special handling instructions you'd see on a real package, like this side up or fragile. First up is the version field. This one's about as simple as it gets. It just contains the number 6. That's it. It's a quick check to confirm, yep, this packet is using the modern Internet Protocol version 6. It's like making sure your package is using the current modern postal system. Next, we have the traffic class field. And this is where it gets interesting. This is the internet's version of a fragile or handle with care sticker. It lets routers give priority to certain kinds of data. Think about it. A video call is way more sensitive to lag than an email, right? This field tells the network, hey, give this video data the VIP treatment to make sure your call is nice and smooth. And building right on top of that is the flow label. So imagine you're sending a whole set of encyclopedias, box by box. The flow label is like marking each one box 1 of 26, box 2 of 26, and so on. It tells the network that all of these packets belong to the same conversation and should get the same priority, keeping them all moving together like a team. Okay, so our special instructions are all set. Now let's get into the fields that help the internet's postal workers, those routers, actually manage the packet's journey from one stop to the next. All right, 2 quick but absolutely crucial fields right here. First, payload length. It just tells the router how big the actual data attached to this header is. Basically, how big are the contents inside the box. And then the next header field is a signpost. It tells the router what to expect after this main header. Are we getting to the good stuff, the data, or is there another optional header with even more instructions? Then we've got the hop limit, and this is just a brilliant little safety feature. Every time a packet goes through a router, this number gets ticked down by 1. If it ever hits 0, poof, the packet is just discarded. This is what stops lost packets from just bouncing around the internet forever and clogging everything up. If you're familiar with the older IPv4, you might know it as time to live, but let's be honest, hop limit is a way more accurate name for what it does. And now we arrive at the most important part of our shipping label, the 2 fields that take up the vast majority of the header's real estate. We're talking about the digital to and from addresses. And these addresses are, well, they're enormous. Just look at that. Each IPv6 address is 128 bits long. That number is so ridiculously large, it's hard to even wrap your head around. It's more unique addresses than there are atoms on the entire surface of the Earth. No joke. So this is the whole mission, right? These 2 fields, source address and destination address, are what it's all about. Each one takes up 16 bytes. One tells the network exactly where the packet came from, and the other tells it exactly where it's going. With a 128-bit system, we are literally never, ever going to run out of addresses. So when you put all of these pieces together, you start to see that the IPv6 header isn't just a minor update. It's a completely different way of thinking about how to label a data packet. It is all about a cleaner, smarter design. And this right here, this is the core philosophy of IPv6. Unlike its clunkier predecessor, IPv4, where all sorts of optional info could bloat the main header, IPv6 is all about keeping that main shipping label clean, simple, and always a fixed size for maximum speed. And this comparison makes the difference crystal clear. Over on the left, IPv4 could have a header of different sizes, which meant routers had to waste time figuring out where the header ended and the data began. But on the right, IPv6 is so elegant, the base header is always 40 bytes. If you need extra instructions, they're just neatly attached in what are called extension headers. It's like having a standard shipping label and then attaching separate customs forms only when you absolutely need them. So, the big takeaway here is that the IPv6 header is so much more than just some technical data. It's a 40-byte lesson in efficiency, in focus, and in really brilliant design. And it makes you wonder, doesn't it? What other incredibly complex systems in our world, whether it's in biology or global logistics, are secretly running on a foundation of just a few simple, elegant rules? It's a